Very good morning. We have started multivariate linear regression. Today we discuss estimation of parameters. So as you have seen earlier in multiple linear regression, the parameter vector, and in multivariate linear regression also you will find out that there will be several parameter vectors for each of the dependent variables. That is what we are going to discuss in terms of estimation of parameters. Let us go to the next.
I think this estimation of parameters we will complete this session by using describing this estimation of parameters. So our equation is y is x beta plus epsilon, and if we estimate, we say y cap equal to x beta cap. Okay. This is our fitted values. This is the estimated parameter, estimated beta. These are observed values. And this you know the error term. Okay. So I have something to say here, something more to say here. What I mean to say that please remember that y is, there are q y variables, getting me. So similarly and p x variables. So that means this beta what you estimate, that will be how many parameters will be there? It will be matrix. What will be that matrix? That will be p plus 1 cross q. Now in MLR what will happen? MLR beta is p plus 1 cross 1. So additionally it is coming like this. So that means if I write like this, y equal to something like this, y1, y2, then it is yq, this y. Then this equal to, we say x beta, can I not write like this, beta 1, beta 2, beta q. So plus you will get what? Epsilon. This epsilon is also having epsilon 1, epsilon 2, like epsilon q. No, q. This is q. This is q. Q will be there. So it is, this equation is nothing but, as we have seen, basically q MLR, q number of MLR means y1 equal to x beta 1 plus epsilon 1, y2 equal to x beta 2 plus epsilon 2. Similarly, yq equal to x beta q plus epsilon q. So this is MLR 1, MLR 2, MLR q. So q MLR is there. Then what will we have to estimate them? What do we have to estimate? We have to estimate beta 1 to beta q, and again beta 1 is p plus q in p plus 1 into q, and everywhere beta 1 is also p plus 1 cross q vector, beta 2 also p plus 1 cross q, sorry, beta 1 p plus 1 vector, this is also 1 vector. Please remember, beta in a nutshell, beta is p plus 1 cross q, but beta 1 p plus 1 cross 1, beta 2 p plus cross into 1, like this, beta q, that also p plus 1 cross 1 vector. So if you go, what is the procedure in MLR? What way we suppose is one y variable and we estimate first the error term. for example, if I recollect y1 equal to x beta 1 plus epsilon 1, that one MLR, what you have done? You have done first find out epsilon 1, that is y1 minus x beta 1. So if I forget about 1, because we are talking this subscript 1, we are talking about only one variable in this case. So general term is y minus x beta. Then you have found out y transpose, that is epsilon transpose epsilon, that is y minus x beta transpose y minus x beta, and then you have that is, this is what we say sum square errors. Sum square errors. Then you have regress sum square, you have found out the derivatives of sum square the SSE with respect to beta, and then you put it to 0, and finally you got the equation like this: beta cap is x transpose x inverse x transpose y. This was the estimation procedure there. This is I am talking in terms of MLR, multiple linear regression. Okay. Now, if we consider y1 in that, we want to keep that notation, then this will be beta 1 and this will be y1. X part remains same, because no way in multivariate regression also x part is unchanged, y part is having additional y's, that is the issue. Okay. So, in the same manner, so what happened ultimately here in this case, when you have collected n into 1 data points, and ultimately your this one is 1 into n into 1, and ultimately SSE is 1 into 1. So, it is a scalar quantity. SSE is a scalar quantity in case of MLR. Now, what will happen in this case? Suppose we are coming to MBLR. MBLR, same thing, y is x beta plus epsilon, but this one we are saying n cross q, this one n cross p plus 1, this one is n p plus 1 cross q, this is your n cross q. So, let us see what will happen. We want to see the our error terms. So, error epsilon is now y minus x beta. So, error is n cross q. In sense also y minus x beta is n cross q. Now, we want to find out the sum square errors like MLR, that is to be minimized. So, if I want to do this, then if I will make like this epsilon transpose, this will be q cross n into epsilon, which is n cross q. So, what is happening here? You are getting a q cross q matrix. So, I cannot say it is a scalar quantity, it is a matrix, and as a result this will give you a structure like this, and your these elements will be sum of I equal to 1 to n epsilon I 1 square. The second diagonal element will be I equal to 1 to n epsilon I 2 square. Similarly, the last diagonal will be I equal to 1 to n epsilon I q square, and off diagonal element will be the covariant structure epsilon I 1 epsilon I 2 like this. So, like this, getting me? So, your error now this your sum square errors is no longer a scalar, it is a matrix, and it is symmetric, it has diagonal elements, the variance component of diagonal element, the covariance component of these error terms, although we assume that the covariance component will be 0, that is our assumption. So, that means this epsilon transpose epsilon is now sum square cross product. Getting me? Earlier you have we have described this sum square cross product epsilon E we can write, or you can say sum square epsilon, let it be E. E stands for error. Okay. Now what we want? We want this matrix should be as minimum as possible, because in MLR we have seen ML that SSE the minimum, then we make derivative, we get derivative of SSE with respect to beta values, we put it to 0 and we got this equation. We want the same thing here. We want this matrix to be minimum as possible. Now if we assume that the off diagonal elements are 0, then what we want? We do not want only that individual diagonal elements will be as minimum as possible. We want the total as minimum as possible. The total sum square across all the y variables as minimum as possible. So what we do, that's why we take the stress of SSCPE or stress of SSCPE, or you can say stress value of epsilon transpose epsilon. This is the diagonal values. So this will be sum total of diagonal values epsilon I1 square, epsilon I2 square, like this, epsilon IQ square. So we will minimize the stress. Your aim is minimize this. Getting me? You have to minimize the stress. So now how do you minimize? What is your control here? Your control is you want the estimate in such a manner that this will minimize this. So your control is beta. Now see, beta is not a single here. Beta is basically, what is the dimension of beta? P plus 1 into Q. So this first one is for beta 1, that is P plus 1 into 1. Second one will be for beta 2. So like this. Getting me? So what do we require? We require that we will find out derivative of stress of this with respect to particular beta. Getting me? Now by saying this, if I say beta k, then it is coming to the univariate case. So beta k, actually again you have j equal to 1 to 0 to 1, 0 to p, number of independent variables. So ultimately beta kj will come. So this thing you will put into 0, So actually what will happen, you can write like this, epsilon, this quantity cannot be, we cannot write like this, that epsilon is y minus x beta. So epsilon transpose epsilon is y minus x beta transpose y minus x beta. So when we are taking derivative trace, that means you are taking stress of this, means stress of this. That means only the diagonal elements are coming. So this, then when you are taking the derivative of this with respect to this, when you are talking about the first beta 1 and that too beta 1 0, then ultimately all other things become 0, only that quantity will be used for derivation. So ultimately it will end into that means with it end into the individual y variables, and as a result when you do this type of manipulation, ultimately you will be getting beta cap, which is nothing but x transpose x inverse, okay, x transpose, I can say y1, y2, like this yq. Getting me? Actually, this quantity will be multiplied to everyone. So, this totality when I write y, then this one is x transpose x inverse x transpose capital Y. What is the difference this between this versus MLR beta? Here y is q number of variable y variables, and there in MLR that will be 1. Okay. So, this is our estimated case. Okay. So, essentially what we can say here, we can say that in this is a least square estimate, and in least square estimate for MBLR, you will get beta cap like this, which is your beta 1 cap, beta 2 cap, beta q is there, q cap, beta 1 q variables are there, and this is nothing but here beta 1 cap means beta 1 0, beta 1 1. So, like this, beta 1 is affected by your p, this is your beta 2 0, then beta 2 is affected by 1, like this beta 2 is affected by p, similarly beta q 0, beta q 1, then beta q is affected by p. This is the case. And this one is, as we are saying that x transpose x inverse x transpose, and we are saying that y is there. So, can we not write like this? This one is similar to y1, y2, like this. This much is not required, like this. Then y1 is again y1 1 2, that in all those things are there. So, nutshell what I mean to say that, I mean to say that if you want to do this one is x transpose x inverse x transpose y1. Similarly, beta 2 cap is x transpose x inverse x transpose y2. So, like this beta q cap is x transpose x inverse x transpose yq. Got it? So, that means you may go for individual MLR, and then you whatever beta value you get, and in MBLR also you will get the same thing. From beta point of view, there is absolutely no problem, because here you are doing q number of computations, here in one computation you are getting q beta vectors. Okay. So, both are same. Then where is the difference? If I get the same beta value while going for q MLR, why should I go for 1 MBLR? The error comes in the not error, the difference comes in error terms, because you have n errors and these errors are multivariate errors. Every observation is multivariate. Earlier in MLR, your n errors are there, but from every univariate error, one observation for one error. But it is a multivariate observation now on q variables. That is the difference. Otherwise, there is no difference. So, that means as error plays the significant role in regression. So, what do you want to do then? That means your all treatment will be in the multivariate domain here, that q every error observation is q data points, q number for y1 to yq. So, test statistics differs. Test statistics will differ. It is similar to ANOVA and MANOVA. If you remember in ANOVA, one response variable and several population in one way, and two way, that two factors and one response variable. Then you have used the ANOVA table, you have gone for F distribution, but in MANOVA what happened? MANOVA you have not got the straight cut this F distribution, that is your SS what I can say factor by your SS error, that means MS factor, that you did not get in MANOVA. Instead you got SSCP there, and then you have gone for different test like Wills lambda test. It happened, it similar thing happened here also. Getting me? So, we will not go for like simple one coefficient of determination R square, we will go for, instead we will go for likelihood ratio test like Wills lambda. Getting me? Huh? That is the issue. So, ultimately your estimation part no problem, but model adequacy test will differ, your test statistics will differ, and but again the diagnostics case you will find out the similarity with MLR. But the beauty of this MLR is that it for the multivariate situation also it can capture. So, many a times we do not go for MBLR, but if MBLR, when there are more number of Y variable, better to test through MBLR, and because similar, it is not tough. Okay. Thank you very much. Next class I will go for in detail the sampling distribution of beta, then model adequacy test and other things.